Now, welcome students. See how to solve this definite integral example. We are solving the numericals of exercise 4.2, question number 3, and which are based on the properties of definite integral. Okay, these properties are very useful in the competitive exam also for CET, JEE, and all. Okay. Now see how to solve this 10 number definite integral example. Write it as 0 to 1 log of x plus 1 upon x square plus 1 dx. If I use property directly, then nothing will work here. So I can do some substitution first, and after that I use the property. So by practice of solving more and more examples, you also understand what you have to do in the integration example. Okay? Now you don't worry about that. So first I, if put 1 plus x square term is there, so put x is equal to tan theta or cot theta. I put x is equal to tan theta here. So after putting the value x is equal to tan theta, I have to calculate the value of dx. Then differentiate with respect to theta. So dx is equal to derivative of tan is sec square theta d theta. Okay. Now the limits are. Now what are the limits here? If x is equal to 0, then theta is equal to tan inverse of 0. So its value is 0. And if x is equal to 1, theta is tan inverse 1 and it is pi by 4. Okay, so the definite integration I is 0 to pi by 4. Log of x plus 1 plus tan theta upon 1 plus tan square theta into sec square theta d theta. Dx value is sec square theta d theta. But 1 plus tan square theta is again is equal to sec square theta, and this sec square theta get cancelled. So 0 to pi by 4 log of 1 plus tan theta d theta is the value of definite integral. Okay. Now by property. Now here I use the property 0 to a. Property number 4. Fx dx value is equal to 0 to a of a minus x dx. By using this property, what is the value of definite integral? Integration 0 to pi by 4 log of 1 plus tan. I replace theta by pi by 4 minus theta, and pi by 4 minus theta here d theta. So 0 to pi by 4 log of 1 plus, what is the formula for tan pi by 4 minus theta? Is tan pi by 4 minus tan theta upon 1 plus tan pi by 4 into tan theta. Okay, clear? Now 0 to pi by 4 log of 1 plus tan pi by 4 value is 1. So 1 minus tan theta on the numerator and 1 plus tan theta on denominator d theta. So simplify 0 to pi by 4 log of 1 plus tan theta plus 1 minus tan theta upon 1 plus tan theta d theta. So minus and plus tan theta get cancelled. 1 plus 1 2. So 0 to pi by 4 log of 2 upon 1 plus tan theta and d theta is the value of integral I. Now for this, if I write 0 to pi by 4 log of numerator minus log of denominator, log 2 minus log 1 plus tan theta by property of logarithm. Here is division of two terms in the log, so I write it as a log a minus log b, log 2 minus log of denominator, and taking separate integration 0 to pi by 4, log 2 is constant. Outside the integral 1 d theta minus 0 to pi by 4 log of 1 plus tan theta d theta. Okay. Now 0 to pi by 4 log of 1 plus tan theta d theta. This value is again I. So this integral is I minus I. It get plus on the left side. So 2I value is equal to log 2 and integration of 1 is theta 0 to pi by 4. So it is equal to log 2 constant as it is, upper limit minus lower limit, pi by 4 minus 0 is pi by 4. So pi by 4 log 2 is the value of 2I, and from this I is equal to pi by 8 to get divided on right side, pi by 8 log 2. This is the final value of definite integration. Okay, clear to all of you. First I utilize the substitution x is equal to tan theta. Then after that integral becomes log of 1 plus tan theta d theta. Then at this situation, if I utilize the property number 4 here, then the integral we have to use the formula for tan a minus b, and after that cross multiplying integral becomes log of 2 upon 1 plus tan theta, and utilize the property of logarithm minus I value is here, and we get 2I is equal to log 2 and integration of 1 is theta, upper limit lower limit. After that we get the value of integral pi by 8 log 2 is the value of definite integration. Now see example number 11. Okay, question number 11. What they have given here, minus 1 to 1 integration minus 1 to 1 x cube plus 2 upon root of x square plus 4 dx. For this kind of definite integration, again before utilizing the property of definite integral, I have to make some simplification. I denote this integral as I minus 1 to 1 x cube plus 2 upon root x square plus 4 dx. If I separately divide numerator by denominator, then what are the two integrals? Minus 1 to 1 x cube upon root x square plus 4 dx plus minus 1 to 1 2 upon root x square plus 4 dx. As you know, function on the denominator is even function x square plus 4 and x square, but on the numerator two different functions are there. One is the odd function and other is constant function. So if I separate these two integrals, this is I1 and this is the I2 integral. For I1, what we have to do? The function is fx is equal to x cube upon root of x square plus 4. So f of minus x cube upon root of minus x square plus 4. So it is equal to minus x cube upon root x square plus 4. So it is minus of fx. Therefore function is odd and I1 value is equal to 0. Okay. Now for I2, I is equal to this integral value is 0 plus what is the value of I2? Minus 1 to 1 2 upon root x square plus 4 dx. 2 is constant. Fx I is equal to constant minus 1 to 1 upon root x square plus 4 dx. So here fx is equal to 1 upon root x square plus 4 and f of minus x is equal to 1 upon root minus x square plus 4. So 1 upon root x square plus 4 is fx. Therefore function is even function. So I is equal to 2 into this integral again becomes 2 times 0 to 1 upon root x square plus 2 square and dx. Okay, now see what is the value 4, and this is in the standard form of integral, so its value is log of modulus x plus square root of x square plus a square 0 to 1. 4. So upper limit is log of 1 plus root 1 square plus 4 minus log of 0 plus root 0 square plus 4. So 4 into log 4 plus 1 5 1 plus root 5 minus log 2. Okay, square root of 4 is 2 log 2. This is the final value, or these two logarithms have first positive, second negative. So write it as in simplified form log of 1 plus root 5 upon 2. This is the value of this definite integral. Okay, 11 number 4 times log of 1 plus root 5 upon 2. This is the final value of definite integration. Now see example number 12. You have given is minus a to a x plus x cube upon, they have given is 16 minus x square dx. Now I am giving this example as a homework for you. Only I give the hint for that. You divide numerator by denominator separately, then get the two functions x upon 16 minus x square first integral I1 and x cube upon 16 minus x square I2. For first integral I1, function is x upon 16 minus x square. Denominator function is even, but numerator both the functions are odd. So here direct you need not to have separate divide the numerator by denominator. Directly your numerator is all odd function. So f of minus x is equal to minus fx. So definite integral value is equal to 0 is coming. You have to solve this 12 number example. Okay, now see the question number 13 of definite integration. 0 to 1 t square root 1 minus t. 0 to 1 t square root 1 minus t dt. Okay, now utilize the properties to solve such type of definite integral examples. 0 to 1 t square root 1 minus t dt, as 1 minus t term is there in square root and outside t has integer power t square. If I use the property number 4, my property number 4, what is it? 0 to a fx dx is equal to 0 to a f of a minus x dx. Okay, so the integral is 0 to 1. I replace t by 1 minus t, that is square 1 minus t dt. So the integral is 0 to 1 minus 2t plus t square, and in the square root 1 minus 1 plus t dt. Minus 1 plus 1 get cancelled. So 0 to 1 minus 2t plus t square into root t dt. So multiply root t to inside. So we get root t minus 2 t raised to 3 by 2 plus t raised to 2 plus 1 half 5 by 2 and integration dt. Take separate integration. So what is it? T raised to 3 by 2 upon 3 by 2. Write it as 2 by 3 minus 2 t raised to 5 by 2 upon 5 by 2. So 4 by 5 t raised to 5 by 2 plus t raised to 7 by 2 upon 7 by 2, 2 by 7 and integration 0 to 1. So what is its value? Upper limit minus lower limit. So 2 by 3 minus 4 by 5 plus 2 by 7 minus 0. So it is coming 10 minus 12 minus 2 upon 15 plus 2 by 7. So it is equal to 16 by 105 is the final value of definite integral. Okay. Now see the next example. Question number 14. What they have given here 0 to pi x sin x into cos square x dx. 0 to pi x sin x into cos square x dx. For this example, again I utilize the property. Okay, see if I denote this integral by I, 0 to pi x sin x into cos square x dx by property number 4, 0 to a fx dx. We have to write the property. What property we have to utilize here? F of a minus x dx. So by this property, what is the value of integral becomes 0 to pi. Replace x by pi minus x sin pi minus x here and cos pi minus x square dx. So its value is 0 to pi. Pi minus x sin pi minus x value by using Allen formula. Its value is sin x and cos pi minus x is minus cos x, but its square is cos square x dx. I multiply these terms to inner terms 0 to pi sin x into cos square x dx minus 0 to pi x sin x into cos square x dx. So this is our original integral I. Okay, we are getting here. So minus I here 8 plus. So 2I is equal to pi 0 to pi sin x into cos square x dx. And write it as a cos x bracket square into sin x dx. So the function, if I do negative sign here and minus 1, minus 1. So this is function fx raised to n, and here it is derivative of function. So by using the property fx raised to n into f dash x dx. So its integration is fx raised to n plus 1 upon n plus 1 plus c. Okay, by using this property on right side, so 2I is equal to minus pi as it is. So its value is cos cube x upon 3 integration 0 to pi. So I is equal to minus pi by 2 there divided on right side and 3 into 2 6. Upper limit minus lower limit. Cos cube pi minus cos cube 0. So it is equal to minus pi by 6. Cos pi value is minus 1. Minus 1 cube is minus 1 minus 1. So minus 2 and minus minus plus. So pi by 6 into 2. So it is equal to pi by 3. So this definite integral 40 number example, its value is pi by 2. Okay. Now see last example of this exercise 4.2. What they have given here. Question number 15. Definite integration from 0 to 1 log x upon square root of 1 minus x square and dx. Okay, I denote this integral as a I. 0 to 1 log x upon root 1 minus x square dx. Here, what we have to do, as there is term 1 minus x square on the denominator, so I can use the substitution on denominator. Okay, in place of x, what we have to use? 1 minus x square term is there, and put x is equal to sin theta. Then differentiate with respect to theta. So dx is equal to derivative of sin theta is cos theta d theta. And if x is equal to 0, theta is equal to sin inverse 0, 0. And if x is equal to 1, theta is equal to sin inverse 1 is pi by 2. So definite integral is 0 to pi by 2. Log of x is sin theta upon root 1 minus sin square theta into dx value is cos theta d theta. Okay, now the integral is 0 to pi by 2 log of sin theta as it is 1 minus sin square theta cos square theta, and its square root is cos theta get cancelled d theta. Okay, now here we have to utilize the property. By property number 4, 0 to a fx dx is equal to 0 to a f of a minus x dx. By utilizing this property, or if I utilize another property, now our integral is from 0 to pi by 2. If I utilize the property, okay, pi by 2, what will be the answer? 0 to pi by 2 log of sin pi by 2 minus theta is cos theta. So it is equal to 0 to pi by 2 log of cos theta d theta. Okay, this is first and this is second equation, and 1 and 2, adding these two integrals on left side 2I is equal to 0 to pi by 2 log of sin theta plus log of cos theta and d theta. Addition of two log, so what we get by property of log of sin theta into cos theta d theta. Okay, I multiply by 2 and divide by 2. 0 to pi by 2 log of 2 sin theta cos theta upon 2 d theta. So the formula for that is 2 sin theta cos theta is sin 2 theta. So log of sin 2 theta upon 2 d theta. So the integral is 0 to pi by 2 log of sin 2 theta d theta minus 0 to pi by 2 log 2 d theta. Okay, 2I value is, now see, if I utilize the property, which property we have to utilize here? See, if I again utilize the property number 5 by in first integral by property 0 to 2a, okay, or 0 to 2a fx dx is equal to 0 to a fx dx plus 0 to a f of 2a minus x dx. Okay, by property number 5. By using this property, what we get on the right side? If I use the substitution for 2 theta, if for I1, this is our integral I1 and this is I2. So I2 we can evaluate directly, but for I1, if I go for substitution here, 2 theta is equal to t. Then after substitution we have to do differentiate with respect to t. So 2 derivative of theta d theta is equal to dt. Okay, so limit if theta is equal to, so d theta is equal to dt upon 2, and if theta is equal to 0, t is equal to 2 into 0 0. If theta is equal to pi by 2, then t is equal to 2 into pi by 2, it is pi. So integral I1 is equal to 0 to pi log of sin t dt upon 2. So it is equal to 1/2 times 0 to pi log of. If I replace t by theta again, okay, so I am getting the value of original integral I 0 to pi by 2 log of sin theta d theta, because value of definite integral does not depends upon the variable involved. In place of t, I write log of sin theta d theta. Okay, so I1 is equal to 1/2 times I from equation first. From this first equation, this is the value of original integral 0 to pi. Okay, I think I made some mistake here by substitution. Yes, here we have to utilize the property number 5. Then we have to integrate or for I1 by property number 5, 0 to 2a fx dx is equal to 0 to a fx dx minus 0 to a, therefore 2a minus x dx. By using this property, what I get here, I1 is equal to 0 to a, means half of it means pi by 4 log of sin 2 theta d theta minus what we are getting here, 0 to pi by 4 log of sin 2a minus x pi by 2 into pi by 2 minus theta. So multiply 2 inside, so what we are getting, pi minus 2 theta is sin 2 theta d theta. Okay, this is value of integral sin 2 theta 0 to pi by 4. So I1 is equal to 0 to pi by 4. For these two integrals, both the integrals are same. So the value of I1 is equal to 1/2 I minus pi by 4 times 2. So you simplify this and you solve the or find out the final answer of this definite integration. Okay, by using the substitution. Now